Hello, so on today's video we're going to show how to commission a HMI from IFM as an Ethernet IP master or scanner to control some CPX-AP-I devices from Festo. So I'm going to step over here to the hardware to show you what I have here today. So this is the IFM HMI. As you can see, I already have something loaded in there. This on the back, this only has 24 volts applied to it, and then it has an Ethernet connection, and that's about it. Nothing special, nothing fancy there. I have a switch there. I'm connected over with this Ethernet cable on the HMI. I'm connected to the CPX API here. So this goes into the switch, and then the switch goes back here, and that's it. So this is the Ethernet IP adapter from Festo CPX API. And then what I do from here is I start branching out to multiple different modules with these cables over here. So there are cables for communication and power. So basically I go from this module to the next one, and so on, right? And then here I have several different devices. So I have input module. This is an input and output module. Valve manifolds. I have another valve manifold where you cannot see it. It's on another table. It's just very far from here. And then I have this IO-Link module. So this IO-Link, this is actually an IO-Link master. It has 4 ports, and with these 2 ports, I'm controlling this electric actuator and this stack light. Okay, so that's the basic topology that we have today. So the objective of today's video is to be able to control all of these devices with this HMI, right? And when I say this HMI, this is actually the PLC and also the HMI, right? So the sequence is pretty simple. I'm gonna switch on some coils, and I'm gonna change the color on the stack light, and I'm gonna also move the actuator. I just press this button, and everything starts working. Just before I forget, I have that button on the HMI, and I also have this other button here physically, and they are just connected, or actually on my sequence, they are just in parallel, so I can press this one or this one. So when I'm from my computer, I'm going to be pressing this one instead. Okay, so let's get back over here. Now, how can we do this? Let's take a look at the topology, right? What do we have? I mentioned that I have several different devices, and you can see them here. So let me open this so you can show you. This is the Ethernet IP adapter that's connected to the IFM HMI, and then from here you can see it says slot 1. So right there, slot 1, and it's this one, right? So this is the Ethernet IP adapter. Then from here I have an 8 digital input module, another 8 digital input module over here, a valve manifold, the one that you cannot see because it's on the other table, and then I have the 4 IO-Link master, 4 port master in IO-Link, and then another valve manifold, and then a combination of 4 digital inputs and 4 digital outputs. So that's basically the topology that I have here. You can see the list, and then here on the top you can see a picture. And if you hover your mouse over each of the modules, you can see the slot number and the cable length as well. What else are we going to do from this web server? I guess I haven't mentioned where I got to this. So this web server, I got to it just by going into Google Chrome. I type in the IP address of this module, the adapter from Festo, the Ethernet IP adapter. I type in that IP address, and this is the splash screen that I get. So there are a couple of things that we're going to use from this web server. So the first thing is going to be the EDS file. So you can click on the EDS file, and that will generate the EDS file for you to download into your computer. You cannot see it, but because the way that I'm recording the video. But when I press in here and then I click on EDS file, I actually get a pop-out window from Windows, and it's asking me for where to save it. So that's just the EDS in its zip file. Okay, so that's one thing. Then the other thing that we're gonna use that's very important is the assembly view. Over here, we're not gonna use the Rockwell L5X project because we're not using a Rockwell PLC. We're using an IFM PLC with CODESYS, but so we're not gonna use that. We're gonna use assembly view. With the assembly view, this allows us to see the sizes for I/O. Okay, so because every module has different sizes, right? For example, an 8 digital input module only has 1 byte of data, so eight connection points, right? But remember that I have multiple devices in my network, right? So this really simplifies the way of determining the sizes of I/O. Here I can just take a look. If I open this drop-down menu, I don't know if you can see it there, maybe not. Well, but there's a drop-down menu here. Let me see if I can fix this real quick. 1 second. Okay, I think that's gonna be better now. So you should be able, yeah, there we go. So now you can see the drop-down menu. And by the way, I can now show you the EDS file. So if I click here on EDS file, you see the different folders, right? So okay, click cancel. Um, so here we were checking the different I/O sizes, right? So if I click on this drop-down menu, I have multiple options. I can set it as exact, as you can see here. It tells me the input. It says the input instance is 100 and then the size, 39 bytes. This is going to be very helpful later on. Then we also get the output, instance 101 for the output, and the size is 49 bytes. Okay. And lastly, I think we're not going to need it today, but it also tells us the configuration. We usually use this in Rockwell. In CODESYS, we're not gonna need it, if I recall. But anyways, let me just get rid of this one. Okay, so now you should see the regular screen. Yeah. What else? What else can I show you from here? I think that's basically it for now. We're not going to get into the details about parameter configuration or any of that because that will take us more detail or more time. But okay, let me go into CODESYS. So here we have a brand new CODESYS instance, and what I'm going to do is I'm going to show you how to do this from scratch. So we're going to create a new project, and then I'm just gonna call this, just gonna leave it as it is, and I'm just gonna save it under my documents. Ecomat display 2. Okay, so let's select the size that we want. Actually, before we do this, I already installed this, but you should install the package manager for this particular device, right? So as you can see, I already have it installed here. If you don't, you can download it from the IFM website and then just click install, and that'll be it. You can install the package and then you can see it as a device in here. Okay, so now let's keep going. So new, and then after you install the package, you're going to get these options. So now this is the model that I have. Ecomat display 2, that's the name of my project. And then let's click OK. So that's going to create a new CODESYS project that's going to load a bunch of different things as default. So now the first thing that we have to do is we have to configure a path for communications, right? For this particular HMI that I have, I already know the IP address, but IFM has a document that tells you how to set an IP address. There's a whole process on how to do it. I'm not going to cover that today. However, I'm going to cover the rest of the stuff. So you double click on here in the in the device on the top. And then once you click on there, you can scan the network. Of course, you got to make sure that you're on the same subnet, and then you're going to find it. Hopefully, you'll find it. So once you find it, you can double click on it, and that will make it the default route for communications for this particular project. So that's it. You set the route, you're good to go for now. We can close this, and I'm just going to start saving now. So let's say, I think it's good practice. The next thing that we have to do here is we have to open the communication here, and then under Ethernet, we're going to add a new device, and this is going to be under Ethernet IP. You're going to find this Ethernet adapter. Okay, so open that, or double click on that. You can double click on you can click add device, and then you'll immediately see an Ethernet instance over here. So you can click on that. Once you click on it, you'll notice that this menu changes. It adapts, right? So once it adapts, you can double click on Ethernet IP scanner, and that will add a scanner a layer below it, and then you see that a bunch of stuff was added here. This is basically adding some additional tasks for the scanning of the I/O of Ethernet IP. You don't have to worry about any of that. That's already done for you. So this was done. Okay, perfect. So now I can double click on the Ethernet IP scanner. And then under here, what I can do is I can add, I'm going to be adding the CPX-AP-I adapter, right? There's two ways of doing this. That one would be as a generic device, and the other one would be by using the EDS. Remember that I showed you where to get that EDS from, where you can get it from the web server on the CPX API, right? So I already installed that EDS, but if you haven't, let me close this. If you haven't installed it, you can click on Tools and then Device Repository, and then you can click on Install and look for that EDS. I already have it here because I installed it previously, but you just do that and then click Open and then you install it, okay? So close, since I already did that, gonna right click on the scanner and then add device, and then you're going to see that my CPX API EP is already in here. So that's good. Double click on that, and then we close this, okay? So far, this is our topology, okay? Well, there's a few things that we have to configure in here. Let's have a look. So from here, the very first thing that we have to do is we have to configure the Ethernet IP, the IP address for the scanner, okay? Don't don't confuse yourself. The IP address for the scanner is not under the scanner, it's actually top above it, and it's right here. So from here, you double click on the Ethernet instance that we created, then click on these three little dots, and that's going to open, as you can see, it goes online, and that's going to open the network adapters that are available on that IFM HMI, and there's multiple potential connections here. I'm gonna select the last one, which is the one that I'm using right now for communications, right? I think that's pretty straightforward. So you're gonna click OK. You can either click OK. I'm gonna click cancel just for now. If you don't do it this way, you can also specify the IP address here, but I usually do it like this. So you can click in here, OK. For whatever reason, I don't know why it says the default gateway to 5 as well. If I recall on my project, I set it to 1. Yeah, so I set it to 1. I don't know why it does it like that, and I don't know if it will work. I think maybe it wouldn't work. But anyways, you also check this option, adjust operating system settings, and then click yes. So after you do that, you're set. Your Ethernet IP scanner has an IP address. Then the next step would be to let me see, what else are we missing from here? Status, no, 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 all of that is good. If we double click on the scanner, we don't really have to configure anything here, so you should be good there. The most important configuration is actually done over here on the adapter, Ethernet IP adapter, or the CPX API, right, that we're configuring today. Here are a few things. As you can see, the IP address, of course, is the most important. Let me bring that window so you can see it. So what's the IP address? This one over here, 192.168.120. If you don't know what the IP address is, you can use this software, which is called Festo Field Device Tool. One thing to mention here is that a brand new CPX API module, an Ethernet IP module, brand new, it comes as a DHCP. So you actually have to assign an IP address to it, okay? You can use bootp, or you can use a DHCP server, or multiple other things. So just wanted to mention that. Okay, so we already know that this is the IP address, so we're gonna put that in here. So it's 1 and then 120. You can leave this like that. It's just checking for the product code, vendor ID, and device type. You can leave it the check match, or you can uncheck whatever you want. And this is really a compatibility check, right? Or electronic keying, as it's also known. The next point is this one, connections. And this is probably, as I mentioned, this is the most important point because this is where you specify the I/O size. And what we're gonna do here is I'm going to delete the connection that comes by default. As you can see, the default is a 16 input, 16 output, but we're not going to use that today. We're going to specify the one that we actually have. So I'm going to delete this connection, and then I'm going to add a new one. So add a connection, and then I'm going to scroll down here, and I'm going to select exact I/O size. Then over here, it's asking me for the input and output size, okay? So remember, where do we get the input and output size? We get it from here, right? So it says that the inputs are 39 bytes and the outputs are 49 bytes. Inputs 39 and outputs 49. So inputs 39 bytes and outputs are 49 bytes, okay? Then the next thing that we have to set here are, let me see how I did it over here. I don't remember if I did multicast or point to point for the inputs. Let's see. Oops. I did point to point. Okay. So let's go back here. You're just going to change this to point instead of multicast. And let's see, schedule, fix, that's all of that's fine. The other important thing, and this is probably the most important thing from within this configuration, is the trigger type. For whatever reason, I had to change the trigger type to change of state instead of cyclic. Usually, I would put it as cyclic with any other device, but for whatever reason, I couldn't make it work. I don't know if this is an IFM thing or what it is, or if it's a CODESYS thing, but I noticed that it does not work under cyclic. Maybe I have another parameter wrong or something, but this is something that we need to check more in depth. For now, I'm just gonna set it as change of state, and when I change it to change of state, you immediately see that these two fields are available now. So change of state, and then you see the inhibit time. I'm not gonna adjust that for now. I'm just going to leave it as is. Okay, so now I'm going to click OK. RPI, I'm just going to leave it at 10. Yeah, I'm just going to click OK. And then you see my connection, right? 10 RPI, 49 of output, 39 of inputs. And that's about it. So let's give it a shot and see what it does. Online login, and then yes, we want to download. Let's see what happens now. If the configuration is correct, I should see green on this tree. There should be green here, and green here. So let's see. Hopefully it is green after it finishes downloading. Okay, so it finished downloading, and as you can see, I have these orange and red triangles, but that's okay at this point because my processor is in stop, or my CPU is in stop, right? So I'm going to start it over here. So start, and hopefully those lights will be green. That's perfect. So this is exactly what we want to see. We want to see these green circles over here. That means that the connection is established. I don't know why there's an exclamation mark here. I saw on their status and it says that there was an error, but it was cleared. I don't know. I will have to take a deeper look into that at this point. I don't know. So I'm gonna close that and go back here. There's one thing here. I wanna see if there's actual I/O communication, right? So I'm gonna go into the mapping, and there's one configuration that I have not adjusted, but I'm going to show you why, the sense of why. You can see here that I have all of the I/Os, so all of the I/Os are listed here, but for whatever reason, the values are like on gray, right? I cannot change any values, or it's not showing me, even if I press the physical button, which is connected to this first byte, I don't see any change. The reason for that is because the CODESYS default is set to not to update them if they are not in use, if the I/O is not in use, if it's not being called by a program, right? So you can change that configuration by going into the device over here and then going into PLC settings and then clicking here, always update variables, and you can set it as enable to always in bus cycle task. and then yes, we can close this and go back, and we're gonna have to do a download here. Yeah, and it's just gonna take half a minute or so. Okay, it finished downloading. I'm going to set it to run. So now it is running, and now I see some data, right? There's something here. There's a value already here. There's a value over here. But let's see the button, right? So I have the button here. I'm gonna press it, and you see the change over here on this first byte. So 1, right? You see it changing there. That's perfect. That's exactly what we wanted to see. Now, if I want to see that's inputs, right? If I want to confirm if I have outputs, what I can do is I can bring a, let me see, how can I do this? Actually, I'm just going to do this transition over here. So you see the valves that are on the back, all of them are switched off right now, right? You can probably see them all the way on the back. Let me point them to you. These ones are off right now, so I'm going to switch them on. I'm going to force those valves to be on. How do I do that? Well, I go back here, and I know that those valves are, let me see, well, let me check my other mapping. That might be easier, because I already added some descriptions here on my other project to facilitate that reading. So let's see, they start on QB38. This is the address. Okay. So if we go to QB38 right here, I can set this to 255 and then write that value. So let me switch to the other camera so you can see. So right now they are on. I'm going to switch them off on CODESYS. They're off. 255. Oops. 255. And right. They're on. Perfect. So that means that we now have communication, right? Inputs and outputs. That's exactly what we wanted to. That's exactly what we wanted to have. Now, if we take a look at the camera, or sorry, at the HMI, if I open this window over here, you can see the HMI, and this is the default project that is loaded, right? At least on the visualization side. If I go back, where can I see this? If I go back here to CODESYS, I log out, and then I go into this portion over here, Visu default, you're going to see that this is the design that they have by default. Okay, so now let me show you my project so you can see the difference. So remember that what we did there was we did exactly the same thing. So I added the inputs. Well, let me just do a recap. I added the Ethernet adapter. I added the Ethernet IP scanner. I added the Ethernet IP adapter. Okay. Then what I did is I went into the Ethernet instance and I configured the IP address. Then I went into the Ethernet IP adapter and I configured the IP address as well. And I also specified the outputs and input size for the size for inputs and outputs. And that's about it, right? Now, what I did here, just to make sure that I had communication on all of the bytes, I created a quick sequence to show control of the multiple devices, right? So this is the screen that I have. You can see the controller is now in stop. I'm going to transition to this other screen, and I'm going to put it on run. So now you can see I made some changes there, and I added some different devices and indicators, so you can see what's happening, right? Now, if I close this, now you can get into your program and you can do a bunch of stuff, right? So what I have on my program is just basically this. I have an indicator for the valve, so I can see if they are switched on or not. I have the button that we saw earlier, so if I press this button, it'll run and it tells me if the valves are on or not. And then it'll tell me the position of the electric actuator, right? This data, remember, this is coming through IO link because these are connected to the CPX-AP-I, and this is connected over just API or the CPX-AP-I platform. But everything is being controlled over Ethernet IP by the IFM HMI. Okay, so that's it. That's the start button. And of course, I'm gonna share this project for whoever is interested in looking at it. It's just a sequence of controlling the switching on and off of the valves and controlling that electric actuator. It's nothing fancy here. I just used pointers because I wanted to try them this time, but nothing crazy. The program is really from here until here, so not many lines there. What else am I missing? I think that's about it. I mean, the rest of the stuff is just creating visualizations and stuff like that. But the main things that you have to pay attention to um, are located, at least for establishing the Ethernet IP communication. The main thing is located here under connections. You have to make sure that you have the right sizes here. Okay, so yeah, I think that video covered pretty much everything. I guess if you wanted to see how the screen looks like, looks pretty nice. I mean, it has good resolution. You can barely see it there on the camera, but I don't know. It depends on the angle, but you can see the transition of the LEDs showing up there and the valves and so on, the pictures. So it's pretty good resolution. Just put it back here. And yeah, I think that with that, we can finish this video. Thank you for watching.